Okay, hello everyone. Today I'm very glad to talk about our new work on the talent management. And my name is Zheng Zhi from University of Science and Technology of China. And the title of our paper is Generative Learning Plan Recommendation for Employees, a Performance-Aware Reinforcement Learning Approach. So first, let me introduce the Enterprise Learning Management System, which can be written as ELMS. The ELMS can deliver, track, report, and manage the learning activities of different employees in a company. And the aim of ELMS is to prompt the individual and organization performances. So here becomes an important question, that is, how to recommend suitable learning plans for different employees. So what should we take into consideration? Maybe the profiles of the employees, maybe how to improve the work performance of different employees by the learning plan, and how to guarantee the rationality of the generated learning plan. And we want to see that existing studies cannot solve this problem. Maybe, for example, the collaborative filtering method, and this method can only recommend courses that are most likely to be learned. However, the relation between the course learning and work performance is neglected because it only makes the click probability to be maximum. And another question is the existing studies can only recommend individual course. However, a learning plan consists of a list of courses arranged in order. So our method can generate a learning plan which consists of multiple courses and at the same time and recommend the learning plan to the employee. So in this paper, our goal is to recommend the learning plans for employees personally. And we want to help the employees to improve their work performance. And we also want to guarantee the rationality of the generated learning plan. For example, a programmer cannot learn courses about arts. And in this paper, we propose a method that is a performance-aware reinforcement learning approach. So our paper proposed a method is called Generative Learning Plan Recommendation, which can be shortened as GLAD. And the GLAD framework has three different components. The first component is a performance predictor. It aims to predict the work performance of different employees based on the profiles and the learning plan. And it's based on a transformer-based architecture. And the second part is a rationality discriminator. It's used to evaluate the rationality of the generated results. The rationality discriminator have the same architecture with the performance predictor, but with the totally different parameters. And the third part is a learning plan generator. It can generate learning plans sequentially. And we used gated transformer to make the IR training more easier. And we also use the cross-attention mechanism. So to train our framework, we propose a policy gradient-based reinforcement learning approach. And inspired by the generative adversarial network paradigm, we use the GAN framework for the different parts of the method to train. And now let me introduce the dataset used in our paper. Our paper used a real-world dataset from a major company. It consists of two different parts. The first part is talent management records. It consists the profile features of employees, including the sparse features, for example, the department, the position, etc., and the dense features, for example, the working age of the employee, etc. And we also have the annual working performance of different employees. And in this data set, there is three different types of work performance, that is excellence, good, or to be improved. And another part of this data set is the learning management records. That is, it contains the course learning records of each employee. And in this data set, we also have the title information of each course. And at the right side is a toy case of our data. And now I will introduce the technical details. And this is an overview of our GLAD framework. You can see that it consists of a learning plan generator, a performance predictor, and a rationality discriminator. So for the performance predictor and the rationality discriminator, and these are the two reward models in our reinforcement learning framework, and they have the same architecture but with different parameters. And the first, we use an MLP-based employee encoder to get the employee embedding from the feature of the employees. And then we use a multi-head attention-based title encoder to get the course embedding. We just input the title and to get the embedding of the course. And after that, we propose a learning plan encoder. In this part, we need to take the order of courses into consideration. So we use a relative position of our attention. That is, we add a bias embedding to the original attention calculation to take the course, the order of course into consideration. And finally, we use a learning plan embedding fusion layer to get the final embedding of a learning plan. And we just input the employee embedding and the learning plan embedding to an MLP layer. And after that, we use a sigmoid layer to get the final output score. For the learning plan generator, we input the employee features and the historical learning record to the generator, and it can generate K courses, which is K is the number we give it. And we use a gated transformer layer to make it easier for the reinforcement learning training. And in this part, we use a relative position of our gated transformer. It is a little bit complicated, so you can refer to our paper for more details. And finally, we get the embedding of historical or new generated courses by the RG transformer layer. And for the gated cross-attention layer, we aim to capture the interaction between original and newly generated courses. And after that, we use a fusion layer for all the context information. And finally, we use an MLP layer and a softmax to get the next probability of the cross. And note that we use a mask layer here because we don't want our generator to generate repeated course. And for the training method, it's also a little bit complicated. First, for the training of the performance predictor, we use an BCE loss, and we aim to let the performance predictor to learn to distinguish between excellence employees and to improve the employees. And for the training for the learning plan generator and the rationality discriminator, we use a generative adversarial imitation learning framework. And for the rationality discriminator, we aim to let the model to distinguish the generated results and the ground truth results. And for the learning plan generator, we use a policy gradient-based reinforcement learning method. And the reward is the weighted sum of the output from the performance predictor and the rationality discriminator. And in this way, our model can achieve a trade-off between the performance improvement and the rationality. And this is the complete training process for our GLAD framework. We can see that we first pre-train the performance predictor, and we pre-train the discriminator. And finally, we use a GAN-based framework to train our discriminator and the learning plan generator. So for the experiments, in our experiments part, we need to demonstrate two different things. The first thing is that our model can predict the performance of different employees accurately. And we use the AUC and log loss for the evaluation metrics. And the second part is we want to demonstrate that our model can generate learning plans with both the performance improvement and and rationality. And for the performance improvement, we use the output of the performance predictor model to we treat this result as the evaluation metric. And for the rationality, we use the discriminator as the output as the evaluation metrics. And we also use a sum of these two parts as the final evaluation metric to capture the trade-off between these two parts. And we can find that our model can achieve best model performance compared with the several different baselines. And here is the parameter sensitivity experiments. And we can find that our GLAD model is robust to different model parameters. For example, we said the alpha parameter is used to control the trade-off between work performance improvement and rationality. You can set it from 0.2 to 0.8, and our model can always achieve good performance. And finally, let me make a summation of this paper. We first propose a novel problem that is a generative learning plan recommendation with work performance awareness. And then we propose a novel model to solve this problem. We propose a generative recommendation framework based on reinforcement learning. And we take both the performance improvement and the rationality of results into consideration. And finally, we achieved a good result on extensive experiment on a real-world data set. And we demonstrate the effectiveness of our model on both performance prediction and learning plan generation. Okay, so this is the end of our talk, and thank you very much. If you have any questions, please feel free to ask me. Thank you.
So until more questions will come in, I got a question. So basically, the paper has aimed to find courses that will help the employees, that will turn poor performance into excellent performance. So I think one of the challenges is how do you distinguish between causality and correlation? It could be, for instance, for programmers, that a good programmer who's skilled and motivated take advanced courses, right? But the algorithm might think that because someone took advanced courses, this is why they are excellent performance. So I wonder how does the algorithm can distinguish between these issues?
Well, the ground truth work performance is given by the human resource in the company. And we use these data to train a performance predictor. And in this way, the performance predictor can contain the knowledge about what is the excellent, what is good. And we use this knowledge in this model, and we use reinforcement learning to let the learning plan generator to learn from this. And in this way, we can guarantee the generated results can be good for the work performance improvement.
I see.
Thank you.
Another question from the audience? Sorry, we got a question from the audience. Has the code been made publicly available yet?
Sorry?
Has the code made publicly available? Is it released on GitHub?
Oh, okay. It's a little bit complicated, but we are trying to make it public. Sorry.
Thank you. Any additional questions? If so, I would like to thank the speaker again.
Oh, thank you.